Good day, everyone. Welcome to Chem Classroom with Auntie Taiwo. Please, if you have not subscribed, kindly do so. Share with your friends, view, like, and share with your friends. Tell them Auntie Taiwo is teaching the nucleus of existence on Chem Classroom on YouTube. So today we'll be going to the thermo aspect of chemistry, the thermodynamics aspect of chemistry. So we'll be talking about the delta H, delta G, the delta S, and the equilibrium constant as well. Okay, so now in a system, in a reaction, you have these three things. Now the delta H is the heat content, which we call the enthalpy. The delta S, the entropy, is the degree of what? Disorderliness or randomness in a system. Then the delta G is the Gibbs free energy, the energy that is available to do work. And for the spontaneity of a reaction, your delta G must be what? Negative. Okay, we'll go there very soon. Okay, so today we'll be doing a practical question on the board, and I have some equations on the board, like a formula that I'll be using to calculate certain things. But before we go ahead, we'll be calculating something under the equilibrium constant. Now the equilibrium constant is the ratio of your what? The product to the reactant concentration. Okay, now I'll be citing an example. I have an example on the board, but the one we have on the board doesn't have coefficients. So I'll be using our ammonia as a very good example, and I'll be writing the equilibrium constant for the forward reaction. So you have something like this, the formation of our ammonia, N2 plus what? The hydrogen gas is a reversible reaction through the Haber process. So you have the 2NH3. So let me balance the reaction. So we have something like this. So my Kp, which is the equilibrium constant, will be what? The product now have the concentration of the ammonia raised to power what? 2 divided by what? My nitrogen concentration in square bracket, please. Then the hydrogen concentration raised to power of what? 3. Okay, so right away we'll be doing the same thing for what we have here. So the first question here, we have the equation, our CO2 plus the hydrogen gas to give us water and the CO. We are being asked to calculate the equilibrium constant, okay? And they have given us some values to what? To substitute. So right away, solution. So I'm going to write the equilibrium constant, Kp. Okay, so the product, I have the H2O. Multiplication, please. Okay, divided by what? The CO2. There is no coefficient, so we are not going to do raised to power of anything. Then the what? H2. Okay, right away we are going to substitute our values. So what was given for the water? 0.3 multiplied by the CO, what was given? 0.45 divided by what? The CO2, 0.65 multiplied by what? For the hydrogen, I have what? 0.27. So calculators, those are with calculator if you are following me. So in all, you're supposed to have 0.77. So that's been done for the first question. So we're going to the second question right away. Now the usage of this formula is being determined by what? By the question. It is what is in the question that will determine how we are going to go about the question. Yes, the usage of the formula is being determined by what? How the question comes. So I have the equilibrium constant at 20. They gave us temperature to be 25 degrees Celsius plus what? For the reaction, I have my hydrogen plus sulfur to give me the hydrogen sulfide, and the equilibrium constant is 6.00 times 10 to the power 5. So we are being asked to calculate the delta H, And mind you, you can be given what? Product and reactant for the three. So it depends on what is being given in the question. But for this question now, we are being given values for the data H for the product and the reactant. So we are going to use this first formula for the data H. We are going to deduct the product from the what? Reactant. So I'm going to have the standard data H equals to delta H product minus delta H reactant. So the delta H product was what was given respectively 0, 0, 0 and what? Minus 21. So minus 21 is the product, minus 21 is the product, minus 0 plus 0. So I still have what? Minus 21 what? Kilojoule, or minus 21,000 joule. Yes, whichever one you choose to use. But as we proceed, we will have to use the one with joule because we have to align with the other units in the question. Okay, so having done for the first one, we'll be moving to the second one, which says what? We should calculate the delta G. Okay, with the formulas that we have here, we can't use the second one here because we don't know what delta S is. We only know what delta H is and the temperature. So I'll be using the first one, which says delta standard delta G equals to minus 2.303 RT and the log K. Okay, we have all the values here given to us. So I'm just going to lift up the values and input it. Minus 2.303. R is what? 8.314 times the temperature is 25 degrees Celsius. So I'm going to convert to Kelvin. So how do we convert? Do you still remember how to convert to Kelvin? 25 plus 273 to give me 298. Multiply by 298. Multiply by log 10. Okay, our log. Where is the equilibrium constant that was given? 6.00 times 10 raised to the power of 5. So where are my calculators? So if you calculate it well, you are expected to have minus 32969.25 joule. Okay, having solved for the second one, so we'll be going to the third one to calculate our what? Our delta S. So we'll be using this formula and we'll make delta S the subject of the formula. So delta G standard equals to what? Delta H minus T delta S standard. Okay, so my T delta S equals to delta H minus delta G. Okay, so my delta S will be delta H minus delta G divided by the temperature right away. Okay, so what's my delta H? My delta H is minus 21 kilojoules, but I'm going to be using the joule, minus 21,000, because the other ones are in joule as well. Then minus, this is my delta G, minus 32,969.25 joule. Divided by what? The temperature is what? 298. So minus 21,000. This will become plus 32,969.25 divided by 298. So in all here, we are supposed to have what? 40.17 joule per mole per Kelvin. Okay, so please, you can solve many examples as possible so that you can get used to what we are actually doing here. It's very simple. Don't be confused with the delta H, G, and S. No. You don't have to be confused. Okay, so please keep watching.